recording.
There's still
Oh.
I got some pepperoni.
There's like some crust stuff.
Where's Audrey? Oh, there she is. Okay. Okay, so here we go. Shift F5. Okay, so I told Brian that I saved my best slides for last, my funniest ones, so hopefully we won't disappoint. We're going to talk. Yes. Yes. There's a lot of 911s coming up, so be prepared. So I think most people who've worked with SQL Server know that scalar function performance has stunk pretty bad since SQL 2000. Hasn't improved much since. The one exception to that I mentioned before was where you do a check constraint with the scalar function. Provided that data doesn't get updated very often, that's not a place where it will necessarily kill your performance. So one recommendation is to avoid scalar functions or defer the execution maybe to your outermost select. Like if you're doing something like paging, where you're dumping records into a tent table, numbering them, filtering them, and then bringing them back, you might defer your scalar function execution to the last select. That's something I do quite a bit, and it boosts your performance tremendously because you're not calling that scalar function on all that data. You're only calling it on a fine subset of the data.
Yeah.
Yeah, get those scalar functions. They're bad for you.
Would you recommend using things like sum or average or any of that kind of mess, or again go back to take it out of there and bring back your data set and then do the?
You can do it on the code side, but I think.
Sometimes you're forced into it.
Yeah, I think the aggregate functions have come a long way. They have been doing quite a bit with the windowing functions since SQL 2005. I think they introduced them at that point, and where you can do like a sum or a row number or whatever with a partition by and over, as opposed to having to do a group by. And the performance of those can be pretty good. They've even done some things that are just way out there, like entile and rank, and there's some new stuff in 2012 that is just, it makes a lot of things that used to be very difficult a lot easier to do on the SQL side, and the performance can be pretty good. There are some cases where if you have access to data on the code side, you might choose to do some of your calculations on that side as opposed to having SQL Server do it. But that would be a kind of a decision you have to make. Right.
What you're trying to do with how much data is going in.
Yep. So now that brings us to 911. So we have a little 911 phone call here. Do not use scalar functions in the where clause or on clause in a join against variable data. This is one of the things that will absolutely kill your performance, and you will get 911 calls for it. It can result in a table or index scan because the function has to be evaluated against every row, and that's a form of RBAR. If you don't know what RBAR is, that stands for row by agonizing row. Very painful. And one of the things I really hate about this is that it's an insidious problem. Why? Because you tend not to notice it when you don't have a lot of records in your table. Why? Because there's less data to run the function against, right? But when your data starts to increase, that's when you start to get problems like timeouts, or you get a parallel plan that increases your CPU pressure, and it ends up with 911 calls. That's all I can say. If you haven't experienced this, you probably eventually will one day, and you'll find that you're getting timeouts, a proc call is failing to run. You go and investigate, you find, oh, it's running over 30 seconds, right? .NET says the default command timeout in .NET is, everybody knows, 30 seconds, right? So if you go beyond that, you're done. Unless you increase that command timeout, which would just be kind of putting a Band-Aid on the problem. The real way to address it is to get rid of the scalar function calls in your where clause or on your join. And this is just something that's very common. I've seen this more times than I can count, and it's never pleasant to have to deal with. So
you're not moving off of this slide until we address the 1995 Nokia.
The 1995 Nokia?
That's especially nice.
That's a modern phone.
I think they used that during your debate.
Oh, yeah, sorry. Yeah, okay, I didn't get it. You're absolutely right. That probably is from 1995, isn't it? That was, again, the only clip art that I could find that was a 911 phone call. So
Wow.
I told you I'd get some laughs from that. I told you.
That was them playing Snake on it.
Right. I told you the best slides were coming. So I don't know if we have time for a demo to illustrate that. Does anybody want to see a demo of? This is one area we might just want to skip. Jeff does. Anybody else?
I wouldn't mind. I mean, you know, a lot of the demos in the book of SQL Server, your basic SQL Server, use a lot of scale functions. If I remember right, in the word clause sometimes. You know?
Yeah, they do. Like
And
date
so
add.
It kind of tricks you into thinking that that's okay. I know I've done that.
I think we all have at one point. Yep. And so here's our demo, and we're going to see avoiding functions in the where clause. And here's why it's bad. Let's see, first of all, what's this going to do? It's going to drop our index if it's not already there, if it is already there. So let's run that first. So this will make our index. And now we're going to do this part. Essentially what we're doing here, I'm going to close the result window just temporarily so we can see what it's doing, is we're going to basically do two things in two different ways that return the same set of results. So this query here is going to do a scan, and notice it's got a function in the where clause. So it's doing date diff day based on the modified date compared to this date here, which is 7/30/2008. Whereas this one just basically checks for modified date greater than the date. So they do the same thing, and you'll see they return the exact same result set. But what we're going to notice is we're going to first look at statistics on this. I'm going to run this a couple times to make sure that we're not using data that's not cached, so it'll be a fair comparison. As it turns out, it looks like it was already cached because we're doing logical reads and not physical reads. So I'll run it one more just to be sure, once more. And sure enough, we see when we're doing the function in the where clause, what do we get? We get same scan count, but look at the logical reads, 335. Now I didn't choose a really extreme case here. I mean, I could have, if I had worked harder on this, I probably could have found you a case where this first one runs way slower than the second one. But my goal here was just to show you're making SQL Server do more work when you put these functions in the where clause, okay? If you don't, if you use plain T-SQL, you do the same thing, you get the same result set, 96 rows here, 96 rows here. If you looked at these, they're the same. It's doing the same thing, bring back the same results. But how much I/O is SQL Server doing? Logical reads 335 versus 4. This is a lot worse. The top one's going to be worse for your performance. If you were to run this against like 1,000,000 rows of data, you would feel the pain. You would definitely feel the pain. And this first one would probably slow to a crawl. And you'd be like, well, when is this going to finish? This is horrible. And this will be one of those things that might get you a 911 call. Hello, the database is down. What's wrong? What's the problem? You go and investigate. Sure enough, you find it's something like this. Now, if you're doing this, like I said, on a small result set, you're probably not going to see this. But if you do this on a large number of rows, that's where you're going to feel the pain. I see some puzzled faces. Are there any questions? Does everybody see? Does everybody get the point here of what's going on? Okay.
Scalar function, those all the SQL Server built-in functions, data add, date.
It can be anything. It can be a user-defined scalar function too. So anything that's a scalar function.
Scalar functions are those functions that return a single result.
Exactly.
That's what qualifies them. So I think anything that you're sending something in, it's returning a single result. So I noticed in your case, what you do is you just store the data, you just did it as
I declared a variable up here.
Operator.
Right. And I just did the comparison. This is plain T-SQL. This is just saying where your modified date is greater than the date specified.
Yeah. If you have to do a scalar on a single query instead of putting it in where clause, stick it in a variable, right? Do it once, stick it in a variable.
Exactly. Anytime you can use plain T-SQL as opposed to a function call and a where clause, you're going to be doing a lot better performance-wise. And one way to do this, in case you've never seen this output before, this is just set statistics IO on. All you do is you turn this on, and it will show you this output. So, a lot of times when I'm doing query performance tuning, as a side note, I will take this output, I'll copy it, and I'll paste it into Excel, I'll split it out, and then I'll actually sum up and compare. Obviously, this is a simple query, but you do this with a complex query that's doing a lot of stuff, and you'll be able to see how you're improving the performance over time. Your goal is to drop the reads. Your goal is to reduce I/O. You reduce I/O, chances are you've improved performance. That's the one thing that I can tell you is like performance tuning 101 for SQL Server. So if you're not used to reading this kind of stuff, get used to reading it and get used to execution plans. They're not really that hard to read. Here we go. You can actually, without even knowing much about execution plans, you can figure out what's going to be bad versus what's going to be good. SQL Server will actually give you a good number of warnings. And you see in this, and we're going to look at this too, because notice here what it's doing. This is another thing that's good to look at, is in this execution plan, the one that's doing the function in the where clause, look what you're getting. You're getting an index scan on non-clustered index. Okay, well, that may seem fine and good, but when you compare it to this one, what's it doing? A seek, right? Same number of rows, but the operation is different. And if you look at the query cost relative to the batch, look where the most time is being spent. In here, 77% is on the one with the function in the where clause. Only 23% is being, that's my ringtone actually. Check out my ringtone. Hey, you stole my ringtone. So you can see from this that you're getting a better operation by not using a function in the where clause. I can't stress this enough. This is one of the most common things I see in performance tuning. This happens all the time. And eventually you will learn not to do this, because you do it enough, you'll get burned by it. And I don't think anybody likes 911 calls, first thing like Monday morning. It's generally not fun. You could pretty much probably go without coffee the rest of the day, or wish you hadn't had any coffee that day. Yeah. So questions about this? Does this all make sense? Okay, let's move on. So identity crisis, and here's another great clip art, SOS. I was trying to be funny here. I hope it worked. Always use scope identity to retrieve the value of the ID record just inserted. This may seem really fundamental, but do you know how often I see code that doesn't do this? It's frightful. And I've seen some really frightening things, like what I'm about to show you that's in the red. Never, ever do that. But we're not there yet. Never use added identity or ident current. Who knows why? Well, it's right here, because they can return values from other scopes. So guess what? You use that, you may get the wrong value back. Okay, somebody goes to your online store and they order something, right? And they pay for it, and it goes to somebody else. Would that be a good thing? No, generally not a good thing. But that's what could happen conceivably if you use these, because you can get identity values from other scopes. And go ahead, Liz.
So I see those how they work as a joke, but would anybody ever actually think to do them?
I have seen that. I have seen these ones in red. I've seen this one on the left in real life. And
in a former life, I have done that. In a former life, I have done an insert, and then I select the max.
This actually does work in a single user environment. It generally does, because if you know the identity key is going to increase, you get the next identity value. It's true that works in a single user environment. As soon as you hit a multi-user environment, though, all bets are off. In fact, that's true for all these approaches, for added identity, ident current, or this approach here.
Now, do you know why added identity is not predictable?
If you read books online,
that one as well.
Books online explains it. Added identity is probably, if you had to compare it to ident current, it's better than ident current, but both are still bad. And the reason why, like I said, is because they can return values from other scopes. I know that added identity can be affected by triggers. So that it may not kill you, if you use it, but if you know the scope identity is better, just use scope identity. Now, I've seen people go on diatribes against ident current. That one's bad. And this one is probably the worst of all, down here at the bottom. This is something you never want to do.
If you have a record that's being inserted while you're processing.
Yes. Yep, you would have a big problem, because SQL Server is a multi-threaded engine, and you could potentially pull back somebody else's ID. If you've ever done this before, I understand, that's kind of why we're doing this, is to spread the knowledge. So if you've ever done any of these things before that we're going to talk about, okay, I know the best way to do it now, so move on. Enough said, right?
That's
See?
why you use SQL Express. All these threads.
Okay. Okay, so we're going to talk a little bit about set operations. This one's going to go pretty fast. This is something pretty simple, but I see it a lot. The vast majority of set operations inside stored procedures revert back to what they were when the stored procedure executes, or when it exits. When you leave that stored procedure, everything gets set back. So a lot of times people will do set no count on, and they'll do set no count off at the bottom. There's no need to do that. If you read books online, it'll tell you all that stuff reverts back to what it was before when you execute the proc. So just, one of those things that it probably won't impact your performance very much, but you don't need to do it. Here's another thing. A lot of people wonder, when should I do set no count on? Ever wonder about that? Okay. Well, what does it do first of all? It turns off the default rows affected message that's returned to the client. That could be rows that are updated or rows selected. It doesn't really make any difference. But it's really only beneficial for select statements and triggers. And I brought this point out about don't set no count on for write operations. Why not? Because the caller may want to know how many rows were affected by that query. And you're going to see why this is the case. And this actually ties in nicely to .NET. This is one of the few things where we're actually talking about something that does relate to .NET specifically. Because you might execute that code there where you execute an on-query and you get the row count back. If you set no count on, your caller's not going to get that row count back. Why does that matter? Anybody here do optimistic locking with row version? Okay. Well, if you do that, you're going to pass. Well, if you ever do optimistic locking, you'll know this because.
Well, I know what optimistic locking is, but what do you say with what?
A row version.
I don't know what that is.
There's a data type in SQL Server, and I believe it's called timestamp as well. Some people may refer to it as timestamp, but it's really the same thing.
Okay, yeah.
And basically what it is, it's a SQL Server generated timestamp for the record. It's just a number, it's an 8-byte integer. And you usually bring it back on the calling code side and you cache it. And when you go to do an update on that record, you pass it back and update your stored procedure and have that in your where clause say where the row version equals the one I passed in. Otherwise, all bets are off because guess what? Somebody else updated the record. Yep. And so this is one case where you definitely wouldn't want to set no count on in your stored proc because then the caller might not, well, the caller might think that the row was updated by somebody else. Yeah, exactly. You'll be constantly prompting the user, hey, I remember the prompt for access. I don't know if anybody's ever seen that. It would always prompt you. It would give you this weird archaic prompt. And I don't think the user would want to see that all the time. It was an awful prompt too, by the way. So,
if I could add, this is why if you guys stealing code, if you're not stealing code, you're not a good software engineer. But the thing is, you got to understand what every line does. Sometimes you just there's no set no count on or set no knock out. You don't even really read the word. What is no count? Well, I guess it was there. I guess it's okay to go there. Like, if you don't know what it does,
yes.
If you don't know what it does when you're stealing code, then you're asking for trouble.
Yep. Excellent point. Okay, so I threw this in here because, this is a question I get asked a lot. Why is my query returning duplicate records? A lot of people have that question. They'll do joins on tables, right? And they'll say, why am I getting duplicates back? It's a perfectly legitimate question, right? But this is just designed to tell you kind of some things to look for because first thing to think about is, well, maybe the data's junky. Maybe you have duplicates in some of the tables, right? But another thing to think about is the relationships between the tables. Is the data, is one table, does it have a one-to-one relationship or a one-to-many relationship with another table? Maybe when you're doing your join, you have to filter down more precisely to get to the records you want without returning duplicates. Joins are just one of those things that can, result in duplicates very easy if you're not watching out for things like the cardinalities on the tables.
Yeah, if you're requesting on the child table the key items you're looking for, but querying back on a parent table, well, for every child record, it might show that the duplicate, parent table and whatnot, and there's a bunch of duplicate data.
Exactly. And a lot of times developers get lazy and they'll do joins and they'll do it as one big gigantic select. This is something I see a lot too. And really the data is not normalized. You can do multiple selects inside a stored procedure. And then on your return call, you can either bring that back with a data set or a reader and you can look at each one of those data tables individually. So, just keep that in mind when you're writing stored procs, that you can actually reduce the amount of data substantially that you're bringing back to the client just by thinking about the relationships between the tables and the data and saying, okay, I don't need to return duplicate data, or I could do this in a more normalized way. Just something to think about.
By the way, you said a key item. I don't know if you're going to cover it later, but it was something that dawned on me much later. Because I was a coder first and got into the database second, was this idea that stored procedure returned a single thing. And that's not the case. And you just kind of hit on that, but I don't know if you go into that deeper.
I don't really, but that is a good point. I mean, when we do .NET code, we do what? Execute scalar, execute reader, we execute non-query, we execute dataset. I mean, that's pretty much all the operations, right? But as Lewis brought out, you can bring back a lot more than you might think. With a scalar, you're bringing back one thing, but with a dataset, you can bring back multiple tables. With a reader, you can bring back multiple tables. There's a lot of options there. It's not just limited to one thing. And a lot of people don't know you can actually get the return value in .NET. For the return value from the stored procedure, you can get the output parameters. So it's good to know all of that. If you're doing .NET code that hits a SQL Server database, that's something that should be kind of on your checklist to know if you're a developer. Okay, so another thing, some more recommendations. Use consistent data types, avoid conversions, and join conditions. This is something that can really kill performance in a very subtle way. Because if you have different data types, a lot of people when they build databases, they won't think about whether they need 16-bit versus 8-bit character data. In other words, Unicode versus ASCII, or whatever the collation of the database is. But 8-bit versus 16-bit, and they'll start doing things like joining on different columns that have different sizes. Under the hood, SQL Server has to do a conversion when you do that. So if you're joining like two character columns together and they're of different sizes, like one is varchar, the other is nvarchar, that's going to kill your performance. So just something to watch out for. In fact, a lot of people, when they build a database, make the decision up front, does this database need to have Unicode data? If it does, everything's going to be nvarchar. Or everything's going to be varchar. So that's a best practice, I think.
Would also setting the size, like say if you have two varchars, but one's 8 and no one's 15, would it also hurt performance as well, even though they're the same type?
That's a tough case. I don't know if the length would affect it. I honestly don't know. That would be something I'd want to check, but I honestly don't know. I'd have to look into that.
It's probably better practice though if it's the same type, or if it's the same value essentially, it should probably be set to the same length.
Yeah, the 16-bit versus 8-bit, in other words, N versus not N, however you want to look at it, varchar versus not nvarchar, that I think is more important than the length of the data. But I honestly don't know the answer to that question. I have to look it up. So, sorry, go ahead.
I was going to say, you made a command decision, means go around that function row to just go largest because storage is cheap and speed is important. So do you think that's a good default or?
It really depends, because I would say if you're in doubt, go with nvarchar.
Yeah.
Make everything 16-bit, because you never know when you could switch to using Unicode data. I mean, how do you know that your company that you're working with, or if you're a consultant, you're doing work for a company, that they're never going to switch to using Unicode data, that they're only going to ever operate in the US and never use Unicode data? That could be a dangerous assumption to make. In some cases it may not, because you may know based on the business that, they're never going to go outside the US, but if they did, you'd be...
But going to the end, we made that decision, always use nvarchar or whatever, and what the downside is just storage.
That's all it is. The only downside is storage. Right. And the point I wanted to bring out here was more about joining on different types. Right. But I think, if you want to play it safe, definitely go with nvarchar versus varchar. Okay, so I talked about the foreign key thing before, so I'm not going to mention that again. Another simple thing, too, you can do is put the schema reference when you refer to an object. DBO, right? If your schema is a default DBO, put it in there. It doesn't take much effort. It makes less work for SQL Server. This is really especially important when you execute stored procedures, because if you don't put it in there, it can cause compile locks. Just something to keep in mind. Add row count is your new best friend. So you can comment on my clip art here. Best friends. Anyway, what does it do? It returns the number of rows affected or read by the last statement. And so those rows may or may not be sent to the client. But why does that matter? How is add@row count a good thing? Well, because whenever you do an operation, add@row count always has the rows affected. Whether you know it, whether you look at it, behind the scenes, it always captures that. It's kind of like add@error. If you ever use that, it always traps an error condition that happens with every SQL execution. Add@row count can tell you how many rows were affected. Like if you dump records into a temp table, you don't have to do select count from the temp table to figure out how many rows are in the temp table. It's right there, add@row count. It's just...
Are you saying like insert in the temp table, select add@row count, as long as it's the following statement, it will always get the...
That's correct.
So whatever the last statement did, it will get whatever rows are affected by.
Exactly right. So it's a great way to figure out how many rows, like there's a perfect example in paging, we do this all the time. If you do paging where you dump records into the temp table, you filter, you row number them, and then bring back a small subset to display it on a page in a web app or something like that. If you do that and you want to know how many rows are in that table, in other words, a total number that are possible, you have to do that for paging a lot of times. You can get it from add@row count. You don't have to do select count from the table. And the performance benefit from doing this is tremendous. I mean, if you would compare what it takes SQL Server to do a select count star from a temp table versus select add@row count, it's ridiculous. There's no comparison, you know. You can also query from sys partitions to get a faster row count than hitting the table directly. I'm going to show you this because I think this is worth showing. What does this code do? Well, it's just pulling basically row count in two different ways. So this is doing it kind of smart way. It's using sys partitions and it's looking for clustered and non-clustered indexes and it's filtering on a specific table. And I want to show you the I/O that's involved. See, the row counts are the same. But look at the messages when we look at the I/O. 7 logical reads versus 273. There's no comparison there. So, and this isn't even using add@row count. This is just using sys partitions. If I used add@row count and I had just done something with that table and I wanted to know how many rows were affected by what I just did, using add@row count would be incredibly faster. There's just no comparison in terms of that versus this, you know, doing a select count star. Worlds of difference. It's just, these are easy things that a lot of developers don't know. You just maybe never been exposed to them, but they can drastically improve your performance in your code.
So say you were to return a data set or something in paging, in your stored procedure, would you return the data set and add@row count as another one of the parameters or something?
Yeah, output parameter would be a great way to do it.
Yep. And you just do it on the stored procedure right there and just send it right out.
Exactly. And prior to 2012, you know, that was probably one of the best ways to do paging. I thought that's the best way I've found so far, is you dump them in a temp table, you filter them. I hate dumping things in temp tables, but you know, if you have a lot of records, you know, you may not be able to do that if you're talking millions or billions of records. But typically, if you've got, you know, thousands or tens of thousands of records, you can do that, you know, and you bring it back. But there's efficient ways to do that and not very efficient ways to do it. Okay, moving right along. Avoid deprecated features and options. I have seen this one before, and avoid deprecated options like set ANSI nulls and quoted identifier off. You know, back in older versions of SQL Server, some people did this because I guess they thought it made them able to write looser SQL. You know, so there may have been a reason why some people did this before, but as SQL Server has progressed, these options have gotten more and more dangerous. I have run into this in production, and you do not want to run into this. You'll get this message: internal query processor error, the query processor could not produce a query plan. I saw this in 2008. For more information, contact customer support services. And the only problem, the only difference in the proc was that it had set ANSI nulls and quoted identifier off. These are majorly deprecated stored proc options. You do not want to turn them off. In Azure, I've seen it fail. There's somebody sitting in this room who I worked with on an Azure stored proc and had it fail because it had quoted identifier off. Not the developer's fault, it's just, you know, because you port code from another system where this is, you know, this kind of thing happens. It wasn't you, Brian. It wasn't you. And I'm not saying anything bad about the developer who did it. That's why I'm not even mentioning the name, but it could have been anybody. It could have been anybody. I just,
Was it you, Matt? Was it you?
Well,
We just said
We have a name of him
it
now,
could have
we
been.
shamed him.
It could have been.
Shame.
I've seen this one. I did see this one. I fixed it though. I fixed it. So, okay.
I want one of those examples every slide.
Okay. That definitely makes it more interesting, doesn't it? Keeps it more lively. Okay, so I kind of use a little tongue-in-cheek here. Would you like to see this message, then use deprecated options? Of course you'd like to see it. So, again, in that same line of thought, image and end text. Anybody ever use those? Image and end text data types. Okay, we all have. We all have. Because in SQL 2000, that's all there was, right? I mean, I don't even know when var binary max and varchar max were introduced. Honestly, I don't. But they're deprecated. Image and end text are deprecated, right? So use var binary max and varchar max instead. Who knows the advantage of the latter over the former?
Doesn't the end varchar be able to dynamically size itself or something?
That's close.
Or the end text is like a block that's
The
on
image
there?
is where it's.
And end text has to be at the end.
Brian, you're
I
onto
wasn't
something.
done.
You are. Well, you're close. You're close, honestly. Image and end text were always stored with pointers. So there would always be a pointer to the lob in the row. But the beauty of varchar max and var binary max is that if they're small enough, they can actually be stored in row. So, a lot of times people would.
If you had to cut me off, Brian, I told the right answer.
This is my group, not yours. But thank you for paying for it.
Oh, goodness.
To that point though, Matt, when you had end text and stuff, they always had to be at the end of a stored procedure and stuff, right? Because you could never put any parameter after them.
I don't
right?
I don't know that you had to do that, but I know that.
Yeah, you had to do that. How old are you? Yeah.
I won't challenge it.
So it has like a pointer in the database to a particular page.
Yeah, it stores the blob actually separately from the row, and so that kind of it degrades performance. In fact, I've actually seen developers hang blob tables off of other tables rather than keeping it with the data itself because of that. And so that's one of the benefits. Really, it's so easy to switch. You just change the data type on the table, you change all your calling code accordingly. It's a very easy kind of plug and play. So there's really no excuse for not doing it. Another thing is, when you upgrade SQL Server, don't just leave the database compatibility level where it was before. This is something that probably happens a lot, and this is probably a source of a lot of database fires where somebody takes like a SQL 2000 database and brings it up to, 2008, and then upgrades it to 2012 and expects everything to go just hunky-dory, and it doesn't, or they find corruption or something later on. Yeah, you always want to set the compatibility up and test. And, you can always read about breaking changes in books online, and you can actually look for deprecated features that are being used inside a database. There's a way to query that. So just something to think about when you're migrating a database. Abusive cursors. See, I told you I'd get to cursors eventually. I told you we'd get there. So the point is, prefer set-based operations wherever possible, and avoid those row by agonizing row operations. And if you must use a cursor for some bizarre reason, which I probably wouldn't agree with, I just kind of put that in there in case there was a heckler to avoid being heckled. But in case somebody really loves cursors, okay, there might be somebody.
I went through a cursor phase, I have to admit. I went to Cursors Anonymous and I'm cured now.
I think we all did at one point. So make the cursor local and read-only, and remember to deallocate it. That's the thing about cursors, you got to deallocate it. So if an error happens, that cursor could still be living somewhere. That might not be good. Remember that cursors and temp tables don't play well together. This is actually in an MSKB article on recompilation, is you don't want to mix the two because you get recompilation as a result. And I won't go into it because iteration is itself something of an anti-pattern in SQL Server, but there are much better ways to do iteration than cursors. So if you really want to know, ask me, but I won't say it now. Okay, more interesting icons. See, I told you the icons were coming. Abuse of dynamic SQL. That's my favorite feature. What's wrong with it? Notice a little face. Isn't that cute? It's a surprise face. You're going to see that face a lot more, actually. So, dynamic SQL is often abused to do things that could be just as easily done without it. And, one of the bad things about dynamic SQL is that it bypasses the permission system and ownership chaining. So it kind of runs like at SA level. And so if you're not careful, it can open you up to SQL injection attacks. And I brought this point out here. By the way, what's the most common cause of website breaches, including exposure of customer data, including credit card numbers?
Dynamic SQL.
You got it, Brian. You win the swag. Here, let me. Okay.
Give some a tap situation there.
Here, what do we have? Paperclip. There you go. Okay. So when improperly implemented, it can prevent plan caching, resulting in poor performance and plan cache pollution, which I've talked about before. So recommendations are, if you have a knee-jerk reaction dynamic SQL, it should probably be no. Having said that, there may be some valid exceptions, and guess what? I'm not going to mention them here, because if you do use dynamic SQL, I want you to own it. I don't want to bless dynamic SQL and say, oh yeah, that's great, that's good. No, that's for you to own. You make that decision. I'll tell you, yeah, use SPXQ SQL with parameterization instead of execute to promote plan caching, and guard against SQL injection attacks by using parameterized queries, but the decision to use dynamic SQL, that's up to you. You're going to own that, not me. That's how dangerous it is. That's why I say your knee-jerk reaction dynamic SQL should be no. Questions on that? Okay, cool. And I will mention one case that I do actually use sometimes in admin jobs, like SQL Server agent jobs. I said I wasn't going to say it, but I did it. Sometimes I will use dynamic SQL for that.
Thanks to the blessing, Matt.
Okay, but I don't bless it. I don't bless it. I don't bless it, okay? I'm not in the blessing business. Yeah. And make sure it's not coming from your website, the data that's passing on.
But Matt said.
Make sure it's not coming from a text box on your website, that data. Yeah, don't do that. Okay, so another interesting one, abuse of DML triggers. And I say DML because that stands for data modification language. I don't know if you know, but there's a thing called DDL triggers. They're actually pretty cool, I think. It's data definition language triggers. You can actually log actions that users perform on tables and procs and all that. All that DDL stuff can be logged to a table, which is really cool if you have customers going in your database and doing stuff and you don't approve of it. You can actually log that and say, here you go, you did this. When they come back and say something broke, and you can go back to them and say, oh, you broke it. That's why. So that's kind of a handy feature, in case you didn't know about it. So what's wrong with DML triggers? Well, they're often abused. And I think probably everybody's been through a trigger phase, haven't they, and they're in recovery.
It was during my cursor.
That's a dark comment.
Every 2 minutes, update, create, dig, go over there and check.
Perfect example. Okay. So you're right. They are powerful, but I think a lot of times they're used as a quick fix or a crutch to do things that could be done more sensibly. The thing that I have the biggest problem with about triggers is that you can forget about them. And that's the point of my next slide, which you're going to see a good example of that, graphical. So triggers, are much more sensitive to recompilation than stored procs. And they can really kill your performance. And most people don't know this, but the number of rows affected by the execution, as measured by the number of rows in the inserted or deleted table in the trigger, is a distinguishing factor in determining a plan cache hit. I know that's read right off the slide, but I mention that because it can really kill your performance. You can get recompilation over and over and over again in triggers, much more so than in stored procs because of that. And so that's one reason to avoid triggers, to make them your one-offs and not your 90%, if you know what I mean. Triggers also prevent the use of the output clause, so they can make optimistic locking more difficult and costly to implement. What do I mean by that? If you do an update on a table, you do update and you want to pull back the row version because you're doing optimistic locking. We talked about that before. And you want to pull back the latest row version because you want to say, okay, I updated this record with this row version, and now I want to pull back the latest row version at the same time using the output clause and give it back to the client so that if they want to do subsequent updates, they can do that. Well, triggers are going to prevent you from doing that because they just do not work at all with the output clause. It makes it basically impossible to use it. And SQL Server will give you an error message if you try. Okay, so, yes?
So, in the DDL, but I manually do that sometimes. You're writing your own logging tables inside of the user database. Do you still consider that DML, or is it only DML if you're writing into that table? Because I've never seen this distinction DML DDL.
Yeah, DML DDL is a distinction that's present in SQL Server, and DML is like your insert, update, delete. That's your data modification language stuff. Anything that affects rows or records, is going to be DML.
Let me give you an example. So if you do a create trigger, what you want to do is go write how many rows are in the table. I mean, this is a ridiculous example, but okay, every time something is created, go to another table and increment by one. Mm-hmm. Just to keep a count or something like that. Do you consider that DDL or DML?
That's a DML trigger.
Because it's modifying data inside the US grid, inside
right.
the database, even though it's not in that table.
Well, actually, it probably would be on the table because a DML trigger is on a table, whereas DDL triggers are.
Oh, I'm sorry. Of course, the trigger is on the table. What I mean is the data that's modifying is somewhere else.
Yeah, and let me actually show you an example of a DDL trigger because there's one in AdventureWorks that probably most people don't know about.
Because that's how I use it most actually. What is modified data in the table or modified data in other tables?
Yes, and that's a DML trigger. A DDL trigger, and that's going to be on the server level, is going to show up under, let me see, or is it going to show in the database? I think it's going to be, I honestly don't know whether it's on the database or on the server level. I think it's on the server level. No, it is on the database. Hold on a sec, triggers. Does anybody see it before I do? There we go, database triggers. So this one right here is one that's built into AdventureWorks. And what this does, in case you never mess with it, is it logs DDL actions. So if someone creates a table, drops a table, creates a proc, drops a proc, creates a trigger, yada, 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 it's going to log that action to the database log table. And this is the thing that I was telling you about is really handy if you've got other people going in and modifying stuff and working on stuff. In fact, everything that was ever done in AdventureWorks is right here in the database log. You can go back and see the guy at Microsoft who was doing this stuff. And I think it even tells you his machine name and all that. So there you go, Derek V Laptop 2, Redmond Derek V. It's all there. I mean, that's the power of a DDL trigger. And that's really, it's an amazing, I think it's a very valuable tool if you have to work in an environment where you could have somebody else doing things in a database, because you can always go back and say, okay, this is something I did versus something that somebody else did, It is very useful for that.
And Matt knows a lot about that. But one of the clients he works for is we actually have little plain database icons.
No names mentioned. No names mentioned. We will protect the innocent. And the guilty. We'll protect the innocent and the guilty. Okay. Okay, so here's my little interesting thing here, my diagram. Oops, I went back by accident. Triggers are often the last thing you think of when something's going wrong. So you click that trigger tree in SSMS, and there it is, surprise, a trigger. And look at that look on that guy's face. Oh no, it's that stupid trigger I wrote many moons ago and forgot about. I have been there, I have done this. I remember what database it was and what table it was, and it wasn't even a big deal. Don't go there. Trust me, you will get trigger remorse, and you do not want to get trigger remorse. So don't abuse triggers. That's all there is to it. It's just one of those things I think everybody goes through a trigger phase and you learn from it, and you're like, I'm not going to do that anymore. For me, one time was enough. I was like, oh, yep, never doing that again. Done with that. Another thing too about triggers is that the error messages that they produce don't really provide often a good reveal the cause of the problem. They tell you something like, I can't write to the transaction log. Well, that's really useful and helpful when I'm trying to figure out what's going wrong. And that's one of the things I hate the most about triggers. Now, having said all that, okay, I know I've pretty much downed triggers. There is one exception. If you need to do validation logic against multiple records or for records in different tables where you can't use a check constraint or unique index, that's a valid use case for DML triggers. I use that. It works. It's very effective. And the way that you can kind of mitigate the last thing I said about the error message, when something bad does happen, you do detect validation failure, roll back the transaction first of all, and then call raise error with a sensible error message. And that's really the way to do it. That's something I would bless. It's a good way to go. And it actually helps protect your data integrity. It's great for when you have, like I said, multiple rows. You need to look at multiple rows, and you need to compare the inserted versus other rows in the table, or you need to look at multiple tables to figure out whether what somebody's done on this table has violated something elsewhere in another table. That's the only case. Triggers are really the only thing that's going to help you with that. Okay, temp tables versus table variables. Why did I throw this in here? Well, I think it's useful to know the differences between temp tables and table variables. And when we talk about recompilation, I think you're going to see why. These are things that I think developers tend to forget about when you're working with SQL Server. And so we'll just run down the list of these before we get into our final demo. Temp tables have statistics, and table variables do not. So that means any estimates, row estimates that you get from table variables are going to be inaccurate. Why? Because it thinks that table variables only have one row in them. That's your row estimate. You got no statistics with table variables. So for that reason, they're not good for working with a large number of records. Table variables, temp tables can be indexed the same way as normal tables, and indexing options with table variables are limited. Temp tables can cause recompilation and have higher recompilation thresholds than regular tables, and we're going to get to that in a minute. Table variables do not cause recompilation. So sometimes if you're dealing with a recompilation problem, it may make sense to look at table variables as a solution. It may not always be the best way to go, but it may be an option. Another thing, the final thing we'll look at is transaction rollback affects temp tables. It does not affect table variables. So if you want to log what happened inside a stored procedure, table variables are a great way to do it. You know, you can say, okay, the transaction blew up, I had to roll it back, but here's why it blew up. And your table variable stores a list of issues that occurred. Another thing to mention about this is looking forward to SQL Server 2014. The CTP2 supports memory optimized table types and table variables. I think I mentioned that before. They aren't in TempDB and they don't use TempDB. I'm actually looking forward to this feature. I think it's going to be really cool. I'd like to start messing with it, but I haven't had a chance to yet. I think it's going to provide some really amazing performance benefits. Okay, so our final subject here is going to be about stored procedure recompilation. Who's ever dealt with stored procedure recompilation? Anybody? Okay, it's not always a bad thing. If your statistics have changed on the underlying tables, then recompilation may give you a better plan. Okay, you may start out with having no records in the table or a very small number of records in the table, and you may get a better plan as a result of recompilation. An interesting thing I just thought I'd throw in here is that rebuilding indexes causes statistics refresh, so recompilation is normal in that case. So recompilation is not always something to get worked up about. You have to really think about it. And and when it's a bad thing, you may get to know about it 911 style. So the symptoms are typically excessive recompil of that are typically high CPU. So if you've got high CPU, how do you know it's recompilation? Well, simple. You look at the plan generation number. And what I mean by that is you query sysdm exec query stats and sort by plan generation num in descending order to find out. I think this is a little bit esoteric a subject for most developers, but I still think it's worth knowing about because chances are you're going to use this less than you are with something like missing indexes, but I still think it's something that every developer needs to know how to do. And the reason I mention that is because if you know about this and you look for this, you guard against it, or you know to look for it, you know what to look for, your coding practices are going to get better because you're going to learn what causes recompilation and you're going to learn to avoid those things. And we'll see that in the demo. So one of the downsides of excessive recompilation is it adds overhead to calling the procedure and defeats the purpose of plan caching. So you're basically taking more time to run your proc than you need to. Where that gets really bad is when you have tons of users applying the same proc simultaneously. You can see what's going to happen. You're going to get high CPU. You're going to have a 911 call. So causes. There's actually a number of causes. I mentioned just a couple here. Performing specific operations with temporary tables. You're going to see that in the demo. And that's probably one of the most common. But again, statistics changing on the underlying table, and the thresholds are defined below. I'm not going to spend a lot of time on this. The point is that the recompilation thresholds are more sensitive for temp tables than permanent tables. There are ways that you can combat that. If you're really interested in the subject, I've got some KB articles you can look at. But let's focus on diagnosing and resolving it. SQL Server Profile is your new best friend. Like Server Trace, never run it against production. I put those in bold and red because you just never want to go there. If you run a Server Trace against production, you're basically putting a big, clamp around SQL Server's neck and saying you're choking SQL Server, essentially is what you're doing, because every single proc call is going to be going through that trace. So there is a default trace in SQL Server, but it's very light. If you put a server trace on, it's very heavy and it's going to impact production, so never do that. And don't ever mess with rerunning captured traces. I just have to say that it's way too dangerous. I've heard of people destroying databases that way and having to restore from backup. So it's a feature you don't want to mess with. The profiler can tell you the specific reasons for recompilation of stored proc. So let's do the demo. Okay, so recompilation demo, here we go. So we're going to create a proc in here that does some really dumb stuff. And what we're going to do, I'm going to go ahead and just create it first. Okay, so I've created my bad proc. And then what we're going to do is we're going to execute it. And we're going to look at what happens when we execute it. And so we've got a query here that checks for recompilations. And it's going to look just at AdventureWorks. So it's already picking up a couple things here, but these are probably really trivial because look at the plan generation number. They're pretty low. You know, sometimes I'll compare plan generation number versus execution count. One thing to know about this indicates the number of recompilations. It does. But you can have multiple recompilations per stored proc execution. You're going to see that in a minute. Because we'll execute the proc maybe once or twice, and you'll see multiple recompilations. So actually a recompilation can occur multiple times for one proc call. Hopefully, even if you've got some bad stuff in your proc, some things you shouldn't do, it may bottom out over time, and you may end up with a stable plan. But having said that, it's better to avoid it when you're coding the proc and knowing what can cause recompilation, because even that first hit is going to increase your CPU. So if you're looking really to optimize performance, it's good to know about this because you're going to end up writing better code. Okay, so who doesn't want to write better code, right? All right, so what we want to do next is we want to hook up Profiler. And this is all pretty straightforward stuff. This is all documented, how to do this. Microsoft has a KB article on it. One thing I forgot to do was I need to filter on the database. So let's see, properties. See, I messed it up, and so I'm going to start over fresh because you know how that is. I'm not going to try to fix it, no. It might end bad. It might end bad, so let's not go there. So you can filter on the database name. I'm just going to filter on AdventureWorks 2012. So we don't get stuff from other databases. Hopefully you won't have to deal with this issue very much. I really hope, but I think it's something good to know about. So what we're going to do is we already created the stored proc. Now what we're going to do is we're going to execute it. And I think I've got two versions of, I've got all kinds of stuff up here, don't I? Let's close that out. And close that out. And yeah, here we go. So we're going to run the proc, and I wish I had two screens because I could show you real time what it's doing, but we'll run it, and then we'll look at Profiler and see what it caught, and let's pause it. So what do we get? We did two executions here, and I did that because I wanted to use different parameters, but what you see here is you see the statement that was executed, and notice I filtered on the SP recompile and the statement recompile because I wanted those included because those are going to tell us the reason for recompilation. So on these two, I got deferred compile, and that happens a lot with temp tables. I think it has to do with name resolution. And then I'm doing some really dumb stuff here where you know what, I should have talked about the proc and what it's doing. But these are all basically the reasons for recompilation. The one I want to focus on, because deferred compile generally happens when you first execute a proc, and it kind of goes away after a while, it'll bottom out. Over time, after you've run it once or twice, really just once, it should bottom out. But what I'm doing here is really dumb, and I want to show you why it's dumb. Because there's better ways to do this. What I'm doing is essentially a little paging proc, and all it's doing is it's dumping some records into a temp table, right? It's filtering on this stuff. And here's the first thing that was kind of dumb that I did. And it doesn't really apply in this case because you're not going to see it as a reason for recompilation, but I wanted to bring it out because it's something you should not do. If you're going to filter in a paging proc, you want to do it when you dump the records into the temp table. Because if you do stuff like this, where you delete records from a temp table, you're just causing more I/O. Why would you want to dump records into the temp table and then delete them later on for filtering? You want to do your filtering here in your where clause, right? This is where I'm doing my filtering for the other two. If I wanted to fix this, I would just say and where cell end date, where at cell end date is null, or cell end date's less than get date, or cell date's less than at cell date. So I mean, it's easy to fix. But I put that in there because I see this done quite a bit where developers will delete records from a temp table and think, okay, I can do my filtering that way. Not a good idea, because for one, you're causing more I/O, and you can get a statistics change from that, which causes recompilation. Here's something really dumb that I'm doing. I'm doing this on purpose because what I'm doing is I'm altering the temp table, and I'm adding a row num column, and I'm having it number the records based on that. That, as of at least SQL Server 2005, that's really ridiculous because you can use row number to do it up here in the select. So there's no reason to do this, but this is actually the reason why the proc is recompiling. See, schema changed, actually temp table changed there, but that's related to this, where I'm doing this alter table. And so if I didn't know going into this what was causing recompilation, Profiler would tell me why, okay? Now that I know, and I've done the research, I could fix this proc, okay? But my goal here was really just to show you, here's how you can do it. You can do this. You probably, will not run into this very often, but hopefully you'll learn. If you do know how to do it, you'll learn what to do to avoid it. Like I said, I'd use row number here instead of doing this kind of stuff. Maybe we've all done this. I'm not getting on anybody's case here, but this is just something that is going to hurt your performance. This will eventually bottom out over time. If you look at this and here, you're going to see where you're getting recompilation right here. Where is that? Create table, this guy right here. I got 6 and 2. I got 2 different query plans from this. I believe they're actually the same, but it did cause recompilation because my plan generation num is 6. I'm sorry if that's a little bit esoteric, but I thought that was something that developers should know about, at least kind of have some familiarity with. I don't expect you to go home and, run that against all your databases and see what's recompiling, but okay. Well, okay. So questions? No questions. Awkward silence. Oh. Awkward silence. I'm going to drop that proc. Okay. I totally understand. Okay, so we're going to wrap it up. Demo and general QA. Where do we go from here? And this is just some things that I thought are helpful if you want to learn more about SQL Server.
I just said my brain was full.
Okay. Okay, no, we're done. We're done. Sorry. I apologize.
I see you put books online. Is there a specific book somewhere online?
No, all of them.
Actually, it's SQL Server Books Online. That's a good question. You can look it up, and you can actually install that, I believe. I don't know if they still offer it as a thing you can install on your computer, but you can look it up on MSDN. Okay, I know that was intense. I apologize for the intensity. No other questions?
Now, the second one down on the last slide.
Yep.
Perhaps you know someone in this room that has some blogs on SQL Server?
Oh, yeah, sure. Actually, I've got some references at the end on some of these articles. If you're interested. Oh, me?
Yes.
I don't have one actually.
That's okay. You're going to start one, right?
I could. Yeah, I could. Okay.
I know someone's wife who's going to be talking to you.
Okay. And so attend my next session. Hopefully I'll have learned to be a better presenter by then, but Brian has given me some good tips, and I will try to keep it shorter next time. So I apologize it was a little lengthy at the end there, but I hope you all enjoyed it and enjoyed your participation, and it's been a pleasure.
Thanks a lot, man.
Matt, why don't you while I talk to